Thanks for joining this discussion. Thanks for joining me. I'm asked to explain your bio.
Good morning, everyone. Dr. K. Amudha, MSc, MPhil, B.Ed, PhD, is an associate professor of physics in the Science and Humanity Department since 2008. Prior to this, she worked for 6 years in Tech Engineering College, Avadi. She has obtained her bachelor degree from Bharati Women's College, University of Madras in 1997, master's degree from Queen Mary's College, Chennai, University second rank in the year 1999. She has completed her MPhil from the Department of Nuclear Physics in the University of Madras, Guindy campus in the year 2000. She obtained her BA degree from NKT College for Women's Clinic in Chennai. She has published 11 papers of reputed national and international journals. She has completed her PhD degree in the year 2019 at the University of Madras, Chennai. Her field of interest includes crystal growth and non-linear optics. She has attended several national and international seminars, conferences, workshops, symposiums, and PhDs in various colleges. She has been lifetime member in professional bodies like IPAT, INENG, and ISCA. Apart from this, she has authorized 3 books in Engineering Physics 1 and Engineering Physics 2 and Engineering Laboratory Manuals. Also, she has authorized a chapter in the lecture notes in electrical engineering in the Springer publication. Thank you.
Ma'am,
Ma'am,
can you
it's
start,
too
ma'am?
much. Yes, ma'am. It's too much of noisy, ma'am. Too much of
Can you
noise.
start, ma'am?
It is too much of noise.
Oh, noise, ma'am. Okay, I will reduce. I will reduce my weight.
You can mute others, ma'am, instead of other than the host.
I'm just informed for mute for others, ma'am. Just informed. Ma'am. Hello, ma'am. Hello, ma'am. Hello.
Ma'am, can you mute from
Ah,
your side? Because I can't even
yes.
talk.
Ma'am.
You mute,
Ah,
mute
so
the.
all the students is muted, ma'am.
Okay, okay. Thank you. My
Okay,
voice
ma'am.
is audible. My voice is audible.
Yes, ma'am.
I'll share my screen, ma'am.
Okay, ma'am.
Is my screen is visible?
Yes, ma'am. Screen is visible. Yes, ma'am. Yes, ma'am.
Okay. Good morning to one and all present here. Am I audible, ma'am? Because still I could hear some noise. Okay, thank you so much. Okay,
I will reduce.
okay. Good morning to all of you present. So today's the topic given to me is introduction of laser. Before we go into detail about laser, let's quickly recap uh, the history of light. Okay. So what is a laser? It is a light amplification by stimulated emission of radiation. And if you look back the history of light, we can divide the history as pre-electricity, age of electricity, and modern lighting, etc. So you all aware of that. Previously, in the early stages, they used a fires as, okay, just a minute. They have used the fires for lighting purpose, and this is considered to be artificial light source. Then it is evolved into oil lamps, candles, and the age of electricity they have used gas lighting, arc lighting, incandescent lighting, etc. In modern lighting technologies, fluorescent lighting was used, halogen lightings, and then slowly evolved into a laser and LED, etc., etc. Now, this is how it evolved from starting from a candle to the latest lighting source what we have nowadays. And let us look into briefly about the history of laser. And 1917, Albert Einstein proposed a process of stimulated emission, and he is a founder of laser, rather we can say, and it remained theoretical for decades. And next, I would like to mention this Mayman, who was the first person to demonstrate the ruby laser, and he's a person in the picture. Then comes the development in the laser technology. And one important person to be noted here is this Patel, who invented the CO2 laser. He is an Indian scientist. He won a Nobel Prize for this discovery. Okay. And nowadays, it has evolved into many applications. We use nowadays laser in medicine, communication industry, defense, and research. And it is progressing day by day. Okay, so light amplification by stimulated emission of radiation. This is coined by Gordon Cloud, and we are into that discussion today. We quickly move into the difference between the incandescent lamp and laser. So, am I audible, ma'am? Am I audible?
Yes, ma'am, audible.
Thank you. So it is ordinary light and laser. If you compare, ordinary light is incoherent in nature, laser is coherent. Ordinary light is directional, not directional. Laser is highly directional, and ordinary light you have in different colors, whereas laser is monochromatic. Ordinary light is less dense, and here it is high dense. And the spreading is more. You could see the picture spreading from the wave trains from ordinary light is greater extent compared to the laser. Suppose if you are projecting a ordinary light to 2 kilometer, 2 kilometer spreading could be seen there. And that's why we prefer to use laser for many applications. So these are all the key characteristics of laser: highly directional, highly intense, monochromatic, high degree of coherence. You could see from the picture what is meant by coherence. The wave trains are in phase with each other, whereas in the case of ordinary light, they go in all directions. Okay. And uh, Einstein in 1917 has given a theoretical uh, suggestion for the stimulated emission. Okay, and he explained the action of laser based on quantum theory, and he used the concept of interaction of radiations with the matter. And, yes, ma'am. Yes. Oh, just a minute.
இப்போ மாறிடுச்சுங்க.
See whether my slides are shared. See, yes. Just a minute, ma'am. Is it okay now? Is it okay? Okay. Okay. Sorry for that. Okay. Now we quickly recap. Light amplification by stimulated emission of radiation, and let quickly recap the history of light. I told you we're starting from the fire, oil lamp, candles, and in the age of electricity, it is evolved into gas lighting, arc lighting, incandescent lighting, etc. And in modern lighting technologies, we use fluorescent lighting, halogen, and LED laser. And this how it is evolved from a candle to a latest technology, laser. And this a very important person to be noted is this Einstein. In 1917, he has given the theory of stimulated emission, and he can even we can call him as a founder of laser. And it has remained theoretical for decades. And we all should be proud that laser evolved only in 19th century. And I would like to mention here T.H. Mayman, who first demonstrated the ruby laser, and then it evolved to many types of laser in the later stage. In 1964, is the slide is changing? Is the slide is changing now?
Yes, ma'am.
Hello? Okay, thank you. In 1964, CO2 laser was invented by Patel. He's an Indian scientist. He won a Nobel Prize for his discovery. Okay. Now, in modern era, the laser, after the invention of laser, it has been used in many applications in medicine, communication industry, defense, research, etc. Now, what is the acronym for laser? Light amplification by stimulated emission of radiation. This was coined by Gordon Cloud, and we are into the detail. Now, if you see the difference between a incandescent lamp and laser, you could see from the picture it is non-coherent. This it is going in all directions, and you could see different wavelength for the ordinary light. Whereas if you see here, the laser is coherent in nature, directional, monochromatic, highly intense. Angular spread is also less. You could see the picture and understand. Ordinary light, when you are projecting for 2 kilometer spread will be there. Whereas for the laser, it is highly monochromatic, going in one direction. They are in phase with each other, etc. Okay, so these are all the key characteristics of laser: directionality, highly intense, monochromaticity, and high degree of coherence. Okay. And because of these surprising properties, it is used in wider applications. Now, Einstein's theory plays a very important role in the evaluation of laser and its type. And he used this quantum theory of light, and he has done an interpretation of interaction of light with the matter. And there are three processes occurring. One is called a stimulated absorption, spontaneous emission, and stimulated emission. When a light falls onto the arrangement of atoms, okay, it absorbs the light and get excited. Then when they are in the excited state, it comes down to the ground state by two processes. One is called a spontaneous emission, another one is called as a stimulated emission. And this is the first process which I am talking about. When a photon is given to the electrons, and he has used a very simple model, two-level system. Okay, one is called as a lower energy state, another one is higher energy state. When photon is interacting, it gains energy and get excited. Okay, after absorption, the electrons will stay back here. And since it comes by the help of a photon and not by itself, it is called a stimulated absorption. And next comes the spontaneous emissions. Once the atom is in the excited state, it is unstable state, we call it will come down. It comes down by two processes. One is called a spontaneous emission by itself, and the photons are emitted randomly. And this is the process which I'm talking about. Spontaneous emission falls down and photons are emitted randomly in all directions. And this is a principle for an ordinary light. What we are talking is this laser. Laser is an artificial light source. It comes by the stimulated emission. When a photon is giving energy to the atoms in the excited state, it comes down and two photons which are very coherent in nature will be emitted. Okay. And this is the process which I'm talking about. So it takes the energy and comes down, and two photons, one photon gives two photons, and the photons gets multiplied like this. So all the process together, okay, before taking the energy, after taking the energy. And he has calculated this Einstein's relation, and what is the conclusions he arrived is, whenever a light falls onto the arrangement of atoms, there will be an upward transitions and there is equal probability of downward transition. And also the spontaneous emission dominates over the stimulated emissions. So how to arrive at this stimulated emissions? For our laser actions, we want the stimulated emission to be predominant. So what is artificial means by which we are able to get the stimulated emission? So these are all the basic principles of laser operation. We should have one population inversion condition. What is that population inversion condition? A conditions where there is a more number of atoms in the excited state than the ground state. And also very important is this metastable state. It is a kind of excited state where it will the atoms are will stay back for a longer time before it fast undergoes a fast decay. And next important is we need a stimulated emission and also optical feedback system. So population inversion, metastable state, stimulated emission, and optical feedback. These are all the basic principles for the laser operations. So this is what I'm talking about population inversion. In normal thermal conditions, if you see a two-level system, E1 is the ground state and E2 is the excited state. You could see from the picture, number of atoms in the ground state will be more than the number of atoms in the excited state. But when that process, when this is the conditions, spontaneous emission will be predominant. But we want the stimulated emission. So that is possible only when the number of atoms in the excited is more than the number of atoms in the ground state. So when the stimulated emission will be effective for the light amplification, and this is called as population inversion, inverting the population, making the number of atoms in the excited state more than the number of atoms in the ground state. And the artificial means of creating population inversion is called as pumping. There are all different methods are there. You have optical pumping, electric discharge method, direct conversion, inelastic atom-atom collision, and chemical reaction. Okay. Now, what is optical pumping? You give off light. By the light energy, if the atoms are excited and the population inversion condition is achieved, that is called as optical pumping. Then the solid lasers will come under this optical pumping. Example, ND arc laser, which I am going to discuss in detail, ruby laser, etc. And then comes this electrical pumping, where the high energy electrons are used to excite the atoms and to achieve the condition called population inversion. Most of these gas lasers will come under this electrical pumping. Say, for example, CO2 laser, argon laser, etc. Then also it is possible for thermal excitation. Heat energy is applied, and by this heat energy also you can make this condition population inversion. And most of this chemical laser will come under this type of thermal pumping. And apart from this, due to chemical reactions also, you are able to achieve the conditions called population inversion, and also by excitation of inelastic collision. So helium neon laser will go by this kind of excitation, inelastic atom-atom collision. You all know what is meant by inelastic. Inelastic, there is no loss of energy, that one gas atoms gets excited, transferring the energy, bringing that energy to the excited state, and then it loses energy and falls down, and the process continues. So most of this helium neon laser will come under this inelastic atom-atom collision. Okay. Now, any laser you study, these are all the basic components of laser. So you should have one lasing medium. Lasing medium may be a solid, maybe a liquid, maybe a gas, etc. And you need some energy to be given. So pumping source is necessary. And also I should get an amplified light, because laser is light amplification by stimulated emission. So I need an amplified light. So you have some kind of optical resonator. What do you mean by optical resonator? Is the mirrors. One side it is 100% reflecting mirror, another side is a partially reflecting mirror. It may be a concave, it may be a plane, etc. Okay, you need so this arrangement is very important for any laser action to occur in any type of laser. Okay. So active medium produces coherent light. Optical pumping source is used to give energy for the atoms. Optical resonator is called as the feedback systems with the mirrors for the amplification. Okay, this is how it happens. The laser actions taking place. You have laser action at ground state, population inversion conditions. Then to begin with, you get a spontaneous emission, and we build up the stimulated emission by the amplification. Kindly, audience, kindly mute yourself now. Audience, kindly mute. Kindly mute. I request I request the audience to mute. Only when you mute, you can enjoy the. Okay, thank you so much. Thank you. Okay. Now this is what I'm talking about amplification. One photons multiplies to two, two multiplies to four, and the photon multiplication happens inside the optical resonator. Okay, and hence we get an amplified output. And based on this, you have the types of laser. Types of laser, you have solid laser, gas laser, liquid laser, and semiconductor laser. Depending upon the active medium, Okay, you have this classifications coming into play. Solid type of active medium we are using, that is called a solid laser. Most of the ruby laser, NdArc laser, or a solid type of active medium is being used. Gas laser, liquid laser, semiconductor laser, fire laser, fiber laser, etc. Depending upon the medium, it is being classified. Then depending upon the pumping method also, you have a classification laser. Optical pumping usually for the solid laser, electrical pumping for helium neon, thermal kind of pumping for CO2 laser, chemical chemical laser will work under chemical pumping. In excitation by inelastic atom-atom collision, most of the gas laser will come under this. And based on the wavelength emitted also, because laser is a very good innovations, you can use it in all range of wavelength. Some laser can be operated in ultraviolet, some will be in visible region itself, some of them are operated in infrared, etc. So the NdArc laser which I am going to talk about is working under this infrared region. And based on the mode of operation, that is the based on the output we get, you are classifying the laser as continuous wave laser, pulsed laser, ultrasound pulse laser, etc. Okay. And the modern laser types are, some of them are listed here. Q switched laser, mode locked laser, etc. So these are all the modern laser, we use it in different applications. So altogether, if you see a laser, it is not only used in health sciences, it is also used in engineering and technology, security, defense. Everywhere we use this laser because it is highly monochromatic, coherent, intense beam, which finds many applications almost in every field. Okay, so these are all the some of the daily applications: holograms, laser shows, whatever we come across, and medical applications, scientific application, industrial application, military applications, and special applications are being listed out here. Okay, now we move on to this NdArc laser. The scientist behind this NdArc laser is Joseph Cusick. He is the first person to demonstrate the laser operation in the year 1964. Okay, now characteristics of laser, if you see, I told you already, this NdArc and ruby lasers are coming under the solid type. And depending upon how many energy levels are involved in the laser actions, it is classified as 3-level laser or 4-level laser. In the case of NdArc laser, 4 energy levels are being involved. So it is called as a 4-level solid laser. An active medium is a solid medium. So you see what is being present. In yttrium aluminum garnet, it is being replaced or doped with the Nd3 plus ions. So it is a doped laser, rather I can say. So yttrium aluminum garnet is a rod where you replace few atoms with this Nd3 plus ions. Okay, and this Nd3 plus ions are going to participate for the laser action. And pumping method here is this optical pumping, and pumping source either a xenon or the krypton flash tube. I would like to mention one important point here. Depending upon the input, you get that output. If it is a flash type, you get the pulsed output. If it is a continuous input, you get a continuous output. Okay. Then optical resonator, I told you it is a feedback system. A part of output should be given as input continuously in order to amplify the light. So what is basically used here is the mirror. So it is 2 ends of the rod. You use a polished mirror, polished with silver. One end it is fully reflecting, other one is partially reflecting. And it is a high power laser, I could say. Power output is 70 watt. The nature of output may be pulsed or continuous depending upon the source what we use. And wavelength of this output will be in 1.06 micrometer. It is in the infrared region. My dear students, I told you there are different types of laser based on the output what we are getting. Here, this is an infrared type of laser. You get only in the infrared region, 1.06 micrometer. Okay. Now, what is this actually, this NdArc laser? I told you it is Nd3 plus ions doped with yttrium aluminum garnet. It is a 4-level laser and it is solid laser, and we get the light only in the infrared region. Okay. Now we just go into detail. This is how it looks. I told you about this optical resonator, highly reflecting mirror. One side 100% is reflecting mirror, other side is partially reflecting mirror. In between is called as an optical resonator. Optical resonator, what all it consists of? It consists of a active medium and also a source, pumping source. Pumping source either may be a flash or it may be a xenon lamp or a krypton flash tube. Okay, depending upon the input we are getting, we get that output either may be a pulsed or continuous. and what comes out through the partially reflecting mirror will be highly amplified output, which we call it as a laser. Okay. So this is the actual picture of the laser, and this is a commercially available NDR in the practical applications. This is how it looks. Whatever we told you, you could see the complete picture of this. You could see the NDR rod, and you will have this kind of mirrors on either side, and xenon flash tube, okay, etc. You could see the picture, and this is the commercially available NDR laser for the practical applications. Okay. Now let us go with this working. Okay, this is how it goes. You could see the four levels involved: E1, E2, E3, E4. Okay, the energy levels of ND3 plus ions in ND-arc laser is being shown here. And since there are four levels, it is called as a four-level laser, and it is a solid laser. Okay. And here I would like to mention about this metastable state, which is a very important factor for the laser action. That is the high level energy state where the lifetime of the charge carrier is made to be more in the range of 10 power minus 8 seconds. You have to stay back, make the atoms to stay back there for some time, spend some time for there, so that the population inversion condition is achieved. Okay, so that the number of atoms here is made to be more than the number of atoms in the ground state. Okay. Now, what is happening here? It is a four-level system, and you are applying a flash tube. You are using a flash tube and supplies the energy to the active medium. What is the active medium? It is Nd Yag crystal. Okay, Nd3 plus and yttrium aluminum garnet crystal. And so this Nd3 plus ion, it gains energy and get excited to E3 and E4 state respectively. And I told you it is the all this excited state is a not stable state, so it has to undergo a transition immediately, undergoing a non-radiative transition, and comes down and settled in this E2. In this E2, once the accumulation starts, once the condition is achieved, when the number of atoms in the excited state is made to be more than the number of atoms in the ground state. Okay, E2 becomes more than the E1. We will get the condition called population inversions, and there will be a transition which is very important, E2 to E1. And the transition from E2 to E1 will give you a wavelength of 1.06 micrometer. And again, from E1 to E2, it comes down, losing the energy, and the process continues. So Nd3 plus ions takes the light energy, get excited, and it undergoes a transition from E4 to E2, E3 to E4, and in the Z2 you will have the more number of atoms. When N2 becomes greater than N1, you get this population inversion conditions, and this transition from E2 to E1 will give you the wavelength of 1.06 micrometer. And this is the infrared region operating laser. Okay, and these things I already discussed about. Okay, why this metastable state is important? Because this E4, E3 are undergoing a transition. Once it goes the higher energy state, it will come down immediately. Then there won't be any condition called population inversion will be achieved. So we need a intermediate energy states where the lifetime of the charge carrier should be increased. So this metastable state is the conditions which is very important in any laser action, in any type of laser. Okay, the same thing, which the same process, whichever I told you, is being with this diagram. Okay, photons taking the energy, it get excited, and in the higher energy states, it is unstable, it comes down. Okay, and once the population inversion is being achieved, and it undergoes a transition, and you get the highly monochromatic coherent laser light is being emitted. Okay, and that's all about this working. Now you just look into this. This is what is actually happening in this NDR rod. So you could see this inside. This is the NDR rod, and either side this elliptical or circular type of mirror is being placed on either side. Okay, well polished. Sometimes the rod is well polished. Okay, and then they place a mirror at both the ends. One side is 100% reflecting, other side is partially reflecting. First, to begin with, you get only spontaneous emission, but when these photons move back and forth, the photons get multiplied. I told you one photons to two photons, and it gets multiplied. And what comes out through the partially reflecting mirror will be highly monochromatic coherent light. Okay. Now, if you look into the advantages of laser, it has got a high gain. It consumes only less power. The efficiency of this laser is very, very high compared to the other ruby laser, other solid lasers. Okay. And it is very important is here we can easily achieve the population inversion conditions. Okay, maybe some difficulties are there with the other type of laser. So these are all the major advantages. Okay, efficiency high and easy to achieve the population inversion conditions, etc. But of course, any laser. Hello, hello. There's only few slides left. If you mute, I can complete. Audience, audience, if you could mute, I could complete because it is causing a disturbance. Okay, thank you so much. Disadvantages of NDR laser, it is high cost. And since heat energy is involved, we need a cooling arrangement to take up the heat. Okay, and maintenance is easy. And these are all the important disadvantages of this NDR laser. Of course, you are doping ND3 plus ion in yttrium aluminum garnet. It is having some kind of complex energy levels. Okay, and you have like other laser, it is also having a wider applications. All this material processing, welding, cutting, etc. can be done with this help of NDR laser. And not only in engineering applications, in medical applications also, endoscopy and dermatology. Okay, most of this cosmetic treatment they use only this NDR laser. Okay, dental surgery and any kind of okay, removal of scar, etc. can be used. All this facial scars can be removed with this NDR laser. And in the communication, they range finders. So NDR laser plays a vital role in the range finding. Target objects can be tracked easily by using this NDR laser. So these are all the important applications. So I have brought some pictures in front of you, how it is used in the cosmetics. And of course, one important drawbacks are the precautions. What you have to observe is you should not expose this NDR laser, any laser, of course, but particularly this is high power laser should not be exposed to the eye directly. So proper precaution has to be taken when you use it for the cosmetic reasons. Okay, and this is how they do. Okay, they use a proper covering of eye and all that precautions, and then they adopt this for a facial treatment, skin removal of scar, etc., etc. Okay, and dental treatment. Okay, and they use this laser because only the target will be getting affected without affecting the neighboring regions. And they use for dental treatment this NDR laser. And laser hair removal and all we used to see in advertisement and all that laser treatment. So they use only this kind of, why? Because it is more advantage, we can have a controlled output. By giving a controlled input we get a controlled out. How pulsed output can be got it with this type of NDR laser. So they are used for laser hair removal, etc. And I told you about the range finding and all can be done with the help of NDR laser. Okay, and you see that cutting, drilling can be done. You see how complex structures within a fraction of time can be done with the help of this NDR laser. Okay, which cannot be done because previously, before the invention of laser, they used to do all this manually. You know, you just imagine how long it takes. But you see, but even though we can't do precisely, okay, so it's all become easy nowadays by using the invention of this kind of lasers. Complex pictures can be drawn. Okay, so thank you. The future belongs to those who master the power of light. Thank you so much. Ma'am, is it okay?
Ah, super, ma'am. Super, super.
Okay. Any doubts from your
Great
side, ma'am?
explanation with examples, ma'am. Okay. Okay. Student, anybody, if you want to doubt, means ask me, the madam.
வாழ்த்துக்கள் வாழ்த்துக்கள்.
Any doubts from your side, my dear? Because with the time is very limited, with a short time, whatever I can do, I have done. Okay. Any doubts from your side? They are asking, ma'am. Any doubts?
Yes, ma'am. Yes, ma'am. 1 minute.
Okay. If there is no doubt, we can close, ma'am.
மேம் மேம் மேம்
You can give them my mail ID, ma'am. They can, I will type my mail ID. If there is any doubt, they can post it to me. Okay.
Okay, ma'am. Okay, ma'am. Okay, ma'am. Boys, any doubt? Please ask me the madam.
Yes, ma'am. Population inversion. What is mean by population inversion?
Population inversion. If you're listening to me, you will not ask doubt. Okay, no problem. I'm very happy to repeat again. In normal energy levels, if you see the distribution of atoms, number of atoms in the ground state will be more than the number of atoms in the excited state. Okay, so this condition is called normal population. But for laser action, we want the number because it is the stimulated emission. Okay, so you have to undergo the transition from the excited state to the ground state. So in order to achieve this condition, the number of atoms in the excited should be made to be more than the number of atoms in the ground state. So this is possible only by artificial means. So that is what I talked about, pumping and different methods and all. Okay. In Lendia laser, we use optical pumping to achieve this population inversion.
Thank you, ma'am.
Why laser is disadvantages for eye?
Ma'am,
Because
what is the difference between ruby laser and Indiac laser, ma'am?
Hello, 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 hello.
okay, ruby laser is a 3-level laser and NDR laser is a 4-level laser. That is a major difference. Energy levels involved for laser action differs. In ruby laser is a 3-level and whereas NDR laser is a 4-level laser. But both are solid type of laser. And somebody asked why we should not expose eye. Okay, it is yes, Sapna, if I'm correct. Not only this NDR laser, any laser should not be exposed directly to the eye. You know why? Because when you put a paper under a laser, you are able to burn the paper. But that we cannot do it with under a sunlight. Source of energy is large. But can I burn a paper by keeping it a paper under the sun? But we can do it with a laser. Why? Because it is highly monochromatic, coherent light. It can be focused to a point. That's why we use laser for operations, not a very big natural source, sun. Okay, because it is spreading in all directions. Are you happy with the answer? Okay, I'll put my mail ID, madam. Anything they can ask me through mail.
Sure, ma'am. Okay, ma'am. Ma'am, once again, wait. Vote of thanks, ma'am.
Okay, ma'am.
Wait, ma'am.
Before ending this session, I would sincerely like to thank Dr. Amudha ma'am for giving this presentation, and I would also like to thank the management and the principal for giving this opportunity. And also, I would like to thank the students for their cooperation, and also the coordinator of this event, Mrs. Abraham ma'am, SNH.
That's all, ma'am. Okay, I would
Um,
like to thank.
um,
I would like to extend my thanks for this management of St. Peter's Engineering College, HOD ma'am, an organizing team for, and also a very good audience for okay patiently listening to me for the past half an hour. Thank you so much for this opportunity. Thank you, ma'am. Thank you, ma'am. Thank you
thank
so
you
much.
so much, ma'am. Thank you so much, ma'am.
Thank you. Thank you.
Welcome,
I'll
ma'am.
call later.
Shall I end?
Uh,
Thank you
thank you
all.
so much for your valuable time.
Thank you. Thank you.
Okay, thank you.